This will be the second video in the series on rational expressions and equations, and what I want to focus on in this video is multiplying and dividing rational expressions. Now, in the first video, we looked at just kind of what is a rational expression, how to evaluate rational expressions, how to simplify rational expressions, and how to determine when a rational expression is undefined. Now, what's going to be really important from that video is simplifying. Okay, so when you're at this point, when you multiply, divide, add, subtract, no matter what you're doing with a rational expression, the understanding is that all of your answers are going to be simplified. So if you haven't watched the first video, it might be worth going back and double checking that. A couple of other things I mentioned in that first video is, one, you have to know how to factor. Everything we do in this series of videos, factoring is going to be a huge part of the process, okay? And that's going to be true for multiplying and dividing rational expressions. In fact, you start by multiplying your numerators, your denominators, everything. So you have to be really, really strong at factoring. So if you're still a little fuzzy on factoring, go back. Make sure you practice the factoring first. The other thing I mentioned in the video is fractions. Rational expressions are basically fractions that contain algebra. So you do need to understand how fractions work. So in this video, we're going to talk about multiplying and dividing rational expressions. It's exactly like multiplying and dividing fractions. So it might be worth going back and reminding yourself, how do I multiply and divide fractions? Okay, so with all that said, let's go ahead and get started. All right, so let me get my pen, make some room here. Whoops. Okay, so multiplying and dividing rational expressions. So we're going to start with multiplying. So multiplying rational expressions. Recall. So remember, I just said that everything we do in this series of videos is kind of similar to what we do with just regular old fractions. And the truth, that is the truth here as well. So recall that if I have A over B and I multiply it by C over D, the result is AC over BD. Now, that's kind of generic. So basically what this is saying is you multiply your numerators, you multiply your denominators. But if you go back to when you were first learning fractions, a lot of times what we did is we would simplify first, then we would multiply. And that's what we're going to do here. Okay, so let's look really quickly at just an example with fractions, and then we'll kind of merge and morph that into rational expressions. And sorry, somebody outside my window is mowing, so you might hear background noise. Let's say we have 18 over 25 and we want to multiply it by 15 over 27. Okay, basically what we would have done when we were multiplying something like this is we would break these down. We would find factors of each of these numbers. So for example, 18 could be written as 2 times 3 times 3. 18 is 2 times 9, 9 is 3 times 3. 25 could be written as 5 times 5. 15 could be written as 3 times 5, and 27 is the same as 3 times 9, and 9 is 3 times 3. So these are basically prime factorizations of each of the numbers that we started with in our numerators and denominators. And then we would cancel factors that were the same in the numerator and the denominator. So I see a 5 in the top, that'll cancel a 5 in the bottom. I see a 3 in the top, a 3 in the bottom, another 3 in the top, another 3 in the bottom, another 3 in the top, another 3 in the bottom. So what am I left with? I'm left with a 2 in the numerator, a 5 in the denominator. So that tells me my final answer here, whoops, I was using blue ink. That tells me my final answer here is 2/5, okay? We want to do exactly the same thing, but we want to do it in this world of algebra. So steps for multiplying rational expressions. I do oftentimes abbreviate rational expression to RAT for rational and EXP for expression. So the first thing we want to do is factor all numerators and denominators. Remember, I said factoring is a huge part of this unit right here. Okay, so make sure you know how to factor. Factoring out a GCF, factoring quadratic trinomials, factoring the difference of squares, factoring perfect square trinomials, factoring sum and difference of cubes. Remember that if the lead term is negative, you factor out a negative GCF. Make sure things are in standard form. So there's a lot that you need to make sure you're really, really good at before you dig into this topic here. Okay, so we factor all numerators and denominators, cancel any common factors, top versus bottom. And then you can leave your final answer in factored form. So there's kind of an assumed step in between step 2 and 3. Once you cancel all common factors, top versus bottom, your final answer is whatever you're left with. So whatever factors are left in the numerator, whatever factors are left in the denominator. And the good thing is you don't have to multiply them out. So you don't have to distribute, you don't have to FOIL or anything like that. You can just leave your factors as they are. So leave your answer in factored form. All right. So let's go ahead and look at examples. And I think I am going to switch to black ink at this point. Okay. So first up, let's say we have x squared minus 9 all over 7 times 49x all over 2x minus 6. So I have two numerators, two denominators. And if you look at the first denominator, it's pretty well factored. There's nothing you can do with 7. If you look at the second numerator, there's not a whole lot you can do there. You could write the 49 as 7 times 7 if you want, or you can just leave it at 49. I'm just going to leave it as 49. Now, the first numerator and the second denominator can be factored. Okay, so I'm going to go ahead and remind you of the difference of squares. So the difference of squares is where your first term is a perfect square and your second term is a perfect square, and they're clearly being subtracted. Difference means subtract. The way this factors is a plus b times a minus b, where a is the square root of a squared and b is the square root of b squared. This is exactly what we have in the first numerator. If we look at the square root of x squared, we get x. The square root of 9, we get 3. So that first numerator is going to factor as those square roots. We want the sum, and then we want the difference. So you add the square roots, you subtract the square roots. And that's all over 7. Now, the first numerator, I already told you, I'm going to go ahead and leave it as 49x. All right. I think that's actually the second numerator. And then the second denominator, I have a GCF of 2. So when I factor out the GCF of 2, I'm left with x minus 3. Okay. So at this point, everything is factored. Now we want to start canceling common factors top to bottom. Okay. I see x minus 3's that cancel. And then if I look at the 7 and the 49, those are both factors, and 7 happens to go into itself and 49. So I would say there's a common factor of 7. 7 divided by itself is 1. And then 49 divided by 7 is 7. So what do we have left? Well, in the numerator, I have an x and x plus 3. And then in the denominator, I have a 2. So my final answer in the numerator, I just get x times x plus 3. And then in the denominator, I get 2. And that's it. That's your final product, okay? And this is what I mean by leaving your answer in factored form. This x times x plus 3, leave it factored. You do not have to distribute the x. So just leave it as x times x plus 3 all over 2. Let's look at more examples. Next up, let's say that I have 2x plus 18 all over x squared plus 8x minus 9 times 7x minus 7 all over 6x plus 42. All right, so we have lots of factoring to do here. I'm going to start with the first numerator. In the first numerator, I have a GCF of 2. So I'm going to go ahead and factor out a 2. And that's going to give me 2 times x plus 9. Now, in the denominator, I have a quadratic trinomial. And this particular quadratic trinomial, the coefficient on the squared term is 1. This is kind of the easy factoring. We can go ahead and start 2 binomials. Each of those are going to start with the variable x. And then what we want to do is we want to find factors of -9, so one positive, one negative, that have a sum of b, the coefficient on x. So if I think of factors of 9, one positive, one negative, the factor pair that works here would be +9, -1. If I multiply 9 and -1, I get -9. If I add 9 and -1, I get 8. So that's the first rational expression. Now for the second rational expression, I have 7x minus 7. Well, in that case, I have a GCF of 7. And so when I factor that out, I just get x minus 1. All right. And then for the denominator, I have 6x plus 42. So when I factor that, I basically just have a GCF of 6. And when I factor that out, I get x plus 7. All right, so now we want to look for any common factors in the numerator and the denominator. So the first thing I notice is an x plus 9. I have one in the numerator, one in the denominator. So that factor of x plus 9 cancels. I also notice that I have an x minus 1. I have one in the numerator, one in the denominator. The factor x minus 1 also cancels. And then the last thing I see that I can cancel is I have a 2 and a 6. I have a 2 in the numerator, a 6 in the denominator. Well, 2 goes into itself once, and then it goes into 6 twice. So now when I clean everything up, what I'm left with is a 7 in the numerator, and then a 2 and an x plus 7 in the denominator. So my final answer is 7 over 2 times x plus 7. And that's it. That's my final product. All right. So again, I think you can see it really clearly in these two examples. You really do have to know how to factor. Okay. If you can't factor, you're going to have a really, really hard time getting through this particular section. All right. Next up, let's say that I have x squared minus 9. Nope, wrong problem. This one I have x minus 9, not x squared. So plain old x minus 9, x squared minus 25 times 3x plus 15 all over 9 minus x. Okay, so the first numerator is factored. There is nothing I can do with x minus 9, so I'm just going to bring it down. My first denominator, I have the difference of squares. And remember this right here? The difference of squares right here. Remember how that works. So I take the square root of x squared, which is x. Whoops. And then I take the square root of 25, which is 5. And then I add the square roots and I subtract the square roots. So x squared minus 25 is the same as x plus 5 times x minus 5. Now, the second numerator, all I can do is factor out a GCF of 3. And when I do that, I'm left with x plus 5. So 3 times x plus 5. And then x, or 9 minus x. This actually came up a good bit in the first video in the series where we were talking about simplifying rational expressions. The issue with this particular expression, 9 minus x, is that it's not in standard form. If I were to put 9 minus x in standard form, I would write it as negative x plus 9. But then we have that issue where the lead term is negative. All right. Well, I don't want a lead term to be negative. So what I'm going to do is factor out a -1. And then that would make this -1 times x minus 9. That is what I'm going to put in that second denominator. Again, you don't want something that's not in standard form. So you want to put it in standard form. And then in this particular case, once we put 9 minus x in standard form, we had that negative lead term, which we had to address. So this is really just negative and then x minus 9. Okay, so everything is factored. Now we can start canceling. It just so happens that the x minus 9s cancel. X plus 5s cancel. And so then what am I left with? Well, in the numerator, I'm left with a 3. In the denominator, I'm left with x minus 5 and that negative 1 that I factored out of 9 minus x. So my final answer here is going to be 3 over x minus 5. And then that negative, what I'm going to do is I'm just going to put it out front. So my final answer is negative 3 over x minus 5. All right. Be really careful with this situation right here. With this situation right here, it doesn't show up a ton, but if you do see something that is not in standard form, put it in standard form. And then a lot of times you end up having to factor out that negative 1. All right. Let's look at the next example. Okay, next up, let's say that we have x squared plus 2xy plus y squared all over 11x squared plus 11xy times x minus y over x squared minus y squared. Let me fix that x, it looks kind of crazy. Okay, lots to do in this problem. Okay, first numerator, it looks a little crazy. The degree of all 3 terms is 2, so you're kind of like, oh, what's standard form? Standard form in something like this, you start with the first variable in the alphabet, and you make sure, and that in this case is x, you make sure all of the terms containing x's are in standard form, and then you follow up with whatever variable is next. So this truly is standard form. X squared, then the 2x to the first y, and then the last term available is just that y squared. Now, when we're factoring it, we can treat this like a quadratic trinomial where the coefficient on the squared term is 1. But we have that weird 2 variable situation. So all we have to do here is start each variable with the first, or start each binomial with the first variable, and then end each binomial with the second variable. And then we look for factors. So we're looking for factors of 1 that add up to 2. All right. Well, the only factors of 1 are 1 and 1. So we're going to go x plus y, x plus y. So x squared plus 2xy plus 1y squared factors into x plus y times x plus y. All right. Now the denominator here, 11x squared plus 11xy, we have a GCF of 11x. So when we factor out 11x, we're left with 1x plus 1y. Excuse me. Now the second numerator, x minus y, that's as good as it's going to get. And then you've got x squared minus y squared. Well, that's the difference of squares again, this stuff we have right here in the corner. So we take the square root of those 2 terms, we add the square roots, we subtract the square roots. So the square root of x squared is just x. The square root of y squared is y. So this becomes x plus y, x minus y. So now everything is factored. I want to start canceling stuff that matches top to bottom. Well, I notice an x plus y in the numerator and an x plus y in the denominator. I notice another x plus y in the numerator and denominator. I notice an x minus y in the numerator and denominator. And here's something that we do. We get really, really lazy in math and we just say, oh, things cancel. Well, keep in mind, every time something cancels, you're leaving behind a footprint of 1. Okay? So even though it looks like everything in the numerator cancels, it does, but we're left behind with these 1s. So in the numerator, I'm left with 1 times 1 times 1. In the denominator, I'm left with 11x times 1 times 1 times 1. So the final answer here would be 1 over 11x. 1 times 1 times 1 is 1. 11x times 1 times 1 times 1 is 11x. So there's your final product. Let me get some water. All right, let's do 2 more problems with multiplication, and then we're going to look at division, okay? So next up, let's say that we have x squared minus x all over x squared, that's an x, minus 13x plus 12 times x minus 12 all over x squared minus 1. Okay. First numerator, In the first numerator here, we have x squared minus x, and all I can do is factor out a GCF of x. So I'm going to factor out an x, and that's going to leave me with x minus 1. Now, in the denominator, I have a quadratic trinomial, and luckily in this quadratic trinomial, the coefficient on the squared term is 1. It's always easier when the coefficient on the squared term is 1 because you can do the shortcut factoring, where you start two binomials with whatever your variable is, and then I look for factors of the constant that add up to the coefficient of the linear term. So I need factors of 12, both positive or both negative, that add up to negative 13. So that tells me I'm looking for two factors of 12, both negative, that add to negative 13. Well, the factors that would work would be negative 12 and negative 1. If I multiply negative 12 and negative 1, I get positive 12. If I add negative 12 and negative 1, I get that negative 13. Now, moving to the second rational expression, I have x minus 12. That's as good as that's going to get, okay? It doesn't factor. However, the denominator, x squared minus 1, that's the difference of squares. And remember, with the difference of squares, we take the square root of each term, we add the square roots, and then we subtract the square roots. So the square root of x is just x. The square root of the square root of x squared is x. And then the square root of 1 is 1. So I get x plus 1, x minus 1. So now let's see if anything will cancel. Well, in the numerator, I have an x minus 1 that cancels an x minus 1 in the denominator. In the numerator, I have an x minus 12 that cancels an x minus 12 in the denominator. So what does that leave me? Well, in the numerator, that leaves me an x. It also leaves me an x plus 1 and an x minus 1. So my final answer is x over x plus 1, x minus 1. And that's it. All right. Let's do one last example of this, and then we'll talk about division. All right. So let's say that we have x squared minus 4 over 2x minus 7 times 2x squared plus 11, x minus 63 all over x squared plus 11x plus 18. A lot going on here. And what I'm going to do is I'm going to hold off on the second numerator. The second numerator is going to take a little bit more work, so I'm going to do that one last. Okay? Let's see here. In the first numerator, I have x squared minus 4. That's the difference of squares. The way we factor the difference of squares is we find the square root of each term, we add them, then we subtract them. So the square root of x squared is x. And then the square root of 4 is 2. So I go plus 2 minus 2. First denominator, 2x minus 7. That's as good as it's going to get. All right, that doesn't factor anymore. And then I'm going to hold off on the second numerator. But the second denominator, I have a quadratic trinomial where the coefficient on the squared term is 1. So I can just start the binomials. I'm going to break it down into two binomials, starting each with an x. And then I want to find factors of 18 that add to 11. Well, if I'm looking for factors of 18 that add to 11, I would just use 9 and 2. All right. Now, what we want to do for the next one, we have 2x squared plus 11x minus 63. All right. So what I'm going to have to do here is the AC method. This is a quadratic trinomial, but in this case, the coefficient of the squared term is not 1. So we do the AC method. So I take 2 times negative 63. All right. And if it helps you, because you are going to get a somewhat large number here, go ahead and use your calculator. Let me rewrite this a little bit. So we get A times C equals 2 times negative 63. So 2 times negative 63 is 126, negative 126. So what we need here is we need factors of negative 126 that add up to be positive 11. That means my larger of the two factors has to be positive. The smaller factor is negative. So we could use 126 and negative 1. We could use 63 and negative 2. And if you don't know the factors of this, just go through your calculator. Okay, so do 126 divided by 2, divided by 3, divided by 4, and so on. Anytime you get decimals, toss it. Anytime you get whole numbers, look to see which pair works. So we could use 42 and -3. We could, let's see, 126 divided by 6. We could do 21 and -6. We could do 18 and -7. Oh, there you have it. What's 18 minus 7 or 18 plus -7? Well, it adds up to 11. So here's what we do. We completely rewrite this polynomial. And what we're going to do is instead of writing plus 11x, we're going to change it to plus 18x minus 7x. And then we'll factor by grouping. So 2x squared stays the same. But again, instead of 11x, I'm going to go plus 18x minus 7x minus 63. So you just use those factors that you found to rewrite the middle term, okay? Now we factor by grouping. Factor by grouping occurs when you have 4 terms. And basically what you do is you factor the first 2 terms, you then factor the second 2 terms, then you look to see if you can factor overall. So looking at the first 2 terms that are underlined in red, I have a GCF of 2x. When I factor out 2x, I'm left with x plus 9. Now for the second 2 terms underlined in blue, notice my lead term is negative. And if my lead term is negative, I have to factor out a negative GCF. So the GCF would be 7. In this case, though, we're going to factor out -7. So that would just leave me with x plus 9. Now, if you notice, the stuff in parentheses matches. That becomes my big overall GCF. And then the second binomial, we're basically undoing the FOIL method here. So the second binomial in my product is going to be made up of those 2 smaller GCFs. So 2x minus 7. So that's what's going to go here in place of my second numerator. I get x plus 9 and 2x minus 7. All right. So now everything is factored. Do the side work when necessary. And now let's look to see what will cancel. Well, I have an x plus 2 in the numerator and denominator. I have an x plus 9 in the numerator and denominator. I have a 2x minus 7 in the numerator and the denominator. And nothing else will cancel. All that I'm left with is x minus 2. So that's my final answer. All right. So that wraps up multiplying rational expressions. Excuse me, I got a sip of water. So basically, factor everything, look for factors top to bottom that'll cancel those, and then whatever is left, that product becomes your final answer. And the good news is we can leave it in factored form. All right. Now, next up is dividing rational expressions. So here's the deal with dividing rational expressions. Always go back to what you know about fractions. And most people remember that when you're dividing fractions, you do a little something special. So basically, if I have A over B divided by C over D, that translates to A over B times D over C, and we basically get AD over BC. So we multiply the first fraction by the reciprocal of the second fraction. And we are going to do the exact same thing with rational expressions. But first, let's go ahead and look at an example so that we know what's happening. Now, with this A over B divided by C over D really equaling A over B times D over C, which equals AD over BC, keep in mind that we actually simplify first, okay? So we simplify on our way to getting A times D over B times C. So let me show you. Let's say we have 8 over 15 divided by 6 over 25. Well, I don't want to do anything until I rewrite this as multiplication. What we find out is that we don't actually know how to divide fractions, but we can convert division to multiplication by multiplying that first fraction by the reciprocal of the second fraction. So 8/15 divided by 6/25 is exactly the same as 8/15 times 25/6. All right. So rewrite it as multiplication first, and then factor everything. 8 is the same as 2 times 4. 4 is 2 times 2. 15 is 3 times 5. 25 is 5 times 5. 6 is 2 times 3. So let's see if anything will cancel. Well, I have a 2 in the top, a 2 in the bottom. I have a 5 in the top, a 5 in the bottom. And then now my numerator is 2s and 5. My denominator's 3s. So I'm left with a 2, a 5, and then a 3 and a 3. So my final answer is going to be 2 times 2, which is 4. 4 times 5, which is 20. My denominator is going to be 3 times 3, which is 9. So 8/15 divided by 6/20 is the same as 20/9, or 2 2/9. All right. So we're going to do the same thing, but with rational expressions. So let's get steps. So steps for dividing rational expressions. Step 1, convert to multiplication. Multiplication. So remember, first fraction times the reciprocal of the second fraction. 2, factor all numerators and denominators. 3, cancel common factors, top versus bottom. And then you can leave your answer in factored form. All right. So between steps 3 and 4, there is this understanding that whatever factors are left that don't cancel, write them out. So the product of those factors becomes your final answer, but you can just leave it in factored form. You don't have to distribute or FOIL or anything for that final answer. All right, let's look at examples. So first of all, let's say that we have 16 over x squared minus x divided by 6x minus 2 all over x squared, x squared minus 1. Yeah. Okay, first thing I want to do before I do anything else, don't factor, don't cancel. The first thing you want to do is write this as multiplication, okay? So I get 16 over x squared minus x times x squared minus 1 over 6x minus 2. Remember, keep the first rational expression the same and then multiply by the reciprocal of the second rational expression. All right, then we factor. First numerator is as good as it's going to get. There's nothing you can do to 16. If you wanted to, you could write it as like 2 times 8 or 2 times 2 times 2 times 2. But for me, I just leave it as 16. Now, x squared minus x, I can factor out a GCF of x. And that leaves me with x minus 1. All right. Now, the first or the second numerator is the difference of squares. So that factors as x plus 1, x minus 1. Okay. Oh, whoops. This is plus 2 right here. So fix this 6x minus 2, it's plus 2. All right. Now, for 6x plus 2, what I can factor out is a 2. So I'm left with 3x plus 1. Okay. So I factored everything. Now I want to see if anything will factor numerator versus denominator. And it just so happens there is an x minus 1 that'll cancel. And then if I look at the 16 and the 2, 2 will go into itself once and it'll go into 16 8 times. So what does that leave us with? Well, it leaves us with an 8 and an x plus 1 in the numerator. In the denominator, it leaves us with an x and a 3x plus 1. So my final answer is going to be 8 times x plus 1 all over x times 3x plus 1. And that's your final answer. All right. Now, remember, you cannot cancel terms. You can only cancel factors. So this is as good as it's going to get. The x in x plus 1 and the x in 3x plus 1 do not cancel their terms. The 1 in x plus 1 and the 1 in 3x plus 1, they do not cancel. Remember, you can only cancel factors, never terms. All right, let's look at the next example. So next up, let's say I have x squared minus 4 over x squared minus 16 divided by x squared plus 2x minus 8 all over x squared minus 2x minus 8. Okay, so remember, first thing I want to do is convert this to multiplication. So my first expression, I keep it exactly the same, and then I multiply by the reciprocal of the second expression. Okay, and now I factor. So x squared minus 4 is the difference of squares. Okay, and the difference of squares, what we do is we take the square root of each term, we add them, we subtract them. So the square root of x squared is x, the square root of 4 is 2, so that's going to factor as x plus 2, x minus 2. And then we have the same thing in the first denominator. We have the difference of squares. The square root of x squared is still just x, but the square root of 16 is 4. So here I'm going to get x plus 4, x minus 4. Now, second numerator, I have a quadratic trinomial, and luckily the coefficient on the squared term is 1. So that's going to factor into two binomials. Each starts with an x. And then basically what I want to do is I want to look for factors of -8 that add up to -2. Okay, so to get a product of -8, one factor has to be positive, one factor has to be negative, and in this case we want the larger factor to be negative. So this factors as x minus 4, x plus 2. If I multiply -4 and 2, I get that -8, and then if I add -4 and 2, I get -2. Now, for this second denominator, again, I have a quadratic trinomial that's going to factor into two binomials. And luckily, the coefficient on the squared term is 1. So again, I'm looking for factors of -8, but this time I want my factors to add up to +2. So I'm going to get x plus 4, x minus 2. Okay? Now, let's see if anything will cancel. Let's see. In the numerator, I have an x minus 2 that cancels an x minus 2 in the denominator. Let's see. I also have an x minus 4 in the numerator that cancels an x minus 4 in the denominator. So here's what I'm left with. I'm left with x plus 2 times x plus 2 in the numerator. You can see that here and here. And then in the denominator, I get x plus 4 times x plus 4. And a lot of times you would see this written as x plus 2 quantity squared, x plus 4 quantity squared. So that would be your final answer. All right. Next up, here's one that maybe can look a little tricky, but it's really not too bad. I have x squared minus 4x minus 5 all over x squared minus 49 divided by just plain old x minus 5. Now, what's different about this one is the second expression is just x minus 5. It's not a rational expression, but keep in mind, I could rewrite that as x minus 5 over 1. So now, when I convert this to multiplication, what it's going to look like is, whoops, let me go back to black ink. It's going to look like x squared minus 4x minus 5 all over x squared minus 49 times 1 over x minus 5. Okay? Now from here, we just start to factor. So my first numerator is a quadratic trinomial, which will factor into two binomials, each binomial starting with an x. And then I need factors of -5 that add to -4. So I would use -5 and +1. Now, my first denominator is the difference of squares. It too will factor into two binomials. And basically what we're going to do is take the square root of x squared, which is x, and then we're going to take the square root of 49, which is 7, and we're going to add those square roots. and then subtract those square roots. And then the second expression, 1 over x minus 5, is just 1 over x minus 5. Nothing there can factor. So at this point, I want to look to see if anything will cancel. And the only thing that's going to cancel is an x minus 5. So that means in the numerator, I'm left with an x plus 1. And in the denominator, x plus 7, x minus 7. So my final answer, x plus 1 over x plus 7, x minus 7. Now, you can leave your answer in factored form like this. However, you might see x plus 1 over, well, what is x plus 7, x minus 7? It's just x squared minus 49, okay? So you could see this. Generally, I just tell my students leave everything factored like what we had originally, the x plus 1 over x plus 7 times x minus 7. All right, let's see what else we have. Let's do maybe, I think we can do 3 more examples of division, and then I'll do one example where we have 3 expressions. Okay, so next up, let's say that we have x squared minus x all over x squared minus 1 divided by x plus 9 all over x squared plus 10x plus 9. Okay, so first things first, we want to rewrite this as multiplication. So I get x squared minus x over x squared minus 1 times x squared plus 10x plus 9 all over x plus 9. Let me get water. Okay. So first numerator, I have a GCF of x. So all I can do is factor an x out. When I factor x out, I'm left with x minus 1. First denominator is the difference of squares. The difference of squares factors into 2 binomials. And basically, we take the square root of x squared and 1. We add the square roots. We subtract the square roots. So this factors as x plus 1, x minus 1. Second numerator is a quadratic trinomial. It factors into 2 binomials, each starting with an x. Luckily, the coefficient on the squared term is 1, so we can do this shortcut. And then basically, I want to find factors of 9 that add to 10. So plus 9 plus 1. And then the second denominator, that's as good as it's going to get. Nothing can factor there. Now, let's see, will anything cancel? I have an x minus 1 in the top and the bottom. I have an x plus 1 in the top and the bottom. I have an x plus 9 in the top and the bottom. So really, the only thing that's left is x. So that would be your final answer. All right. So the next example is going to look kind of crazy. So the next example, we have 2 over x plus 4, all of that over 10 over x squared minus 16. Now, this looks crazy. It's like one big fraction where the numerator and denominator are made up of separate fractions. But just keep in mind this big fraction bar right here, it really just means divide, okay? So this is really the same as 2 over x plus 4 divided by 10 over x squared minus 16. So just be on the lookout for that. Most books will throw those at you every now and then just to kind of like see if you're on your game or not. So just know that if you have something that's written like this one giant fraction where the numerator and denominator are made up of their own rational expressions, it really just means divide. So we would convert to multiplication. So I would get 2 over x plus 4 times x squared minus 16 over 10. And then I factor. Well, 2 over x plus 4 is as good as it's going to get. Nothing can factor there. In the second expression, x squared minus 16 can factor. It's the difference of squares. It factors into 2 binomials, each starting with an x. And then we basically want the square root of each term, and then we add them and subtract them. So it's going to be x plus 4, x minus 4. And then all of that is over 10. So let's see what cancels. Well, the x plus 4s in the top and bottom cancel. And then 2 and 10 reduce. 2 goes into itself once, 2 goes into 10 5 times. So I'm left with x minus 4 over 5. And that is my final answer. All right. Do you see how important it is to know your factoring like really, really, really well? If you don't know the factoring, this is going to be incredibly difficult. Okay. Now, let's say one more example like this, and then we'll do one big example where we're dividing, where we have three expressions. So for the last example of just basic division, we have x squared plus 4x plus 4. We have x squared minus 4 divided by x squared minus 2x minus 8 all over x squared minus 6x plus 8. Now, first things first, we are dividing, and the way we divide is we keep the first expression the same, and then we multiply by the reciprocal of the second expression. All right. So first numerator is a quadratic trinomial. You can factor it by finding factors of 4 that add to 4, or you might recognize that it is a perfect square trinomial. Either way, you should get x plus 2, x plus 2. First denominator is the difference of squares. It factors into two binomials. We take the square root of x squared and 4, we add them, we subtract them. Now, the first denominator is a quadratic trinomial. It factors into two binomials, each starting with an x, and then we fill it in with factors of 8 that add to -6. So we could use -4 and -2. When I multiply -4 and -2, I get that +8, but when I add them, I get that -6. Second denominator is, again, quadratic trinomial. Luckily, the coefficient on the squared term in both of these cases was 1, so we can fill each binomial in starting with an x. And then I need factors of -8 that add to -2, so I would use -4, +2. When I multiply -4 and 2, I get -8. When I add them, I get -2. So now let's see, will anything cancel? So in the numerator, there's an x plus 2 that cancels 1 in the denominator. There's another x plus 2 that cancels another one in the denominator. I have an x plus 4 that cancels 1 in the denominator. And then I have an x minus 2 that cancels an x minus 2 in the denominator. So what in the heck is going on here? Everything cancels. Well, yes, but remember, I've already said that we get very lazy sometimes and we just cancel things like they poof, disappear. But when you're dividing and things cancel, you're leaving behind these little footprints of 1. Things don't just willy-nilly disappear. They either cancel to become 0 or they cancel to become 1. With division, they cancel to become 1. So your final answer here is 1. And that's it. All right. The last example we'll do in this video is 3 expressions, and we're going to be dividing. Okay. So it works the same way. You just have 3 expressions instead of 2. So let's say, excuse me, let's say I have x squared plus x minus 12 all over x squared minus 3x minus 54 divided by x plus 4 all over x squared plus 5x minus 6 divided by 9 minus 3x all over x minus 9. Well, we're dividing. We have 3 different expressions, and basically what we're going to do is we're going to convert everything to multiplication. Okay? So first expression stays the same. Whoops, I forgot next. Let me start over. And then I'm going to multiply by the reciprocal of the next expression, which is x squared plus 5x minus 6 all over x plus 4. And then I'm going to multiply by the reciprocal of the final expression, x minus 9 over 9 minus 3x. Okay, so now we factor. First numerator is just a quadratic trinomial that's going to factor into 2 binomials, each starting with an x. And then we want factors of -12 that add to 1. Those factors would be +4, -3. All right. First denominator, again, we have a quadratic trinomial. All right. And it's going to factor into 2 binomials. Luckily, the coefficient on the squared term is 1, so we can do the shortcut, start each binomial with x. And then we need factors of -54 that add to -3. Okay. Now, if you have trouble, like some of these are really easy to see in our head, some of them not so much. So if you're unsure, We need to find factors of negative 54. That means one factor is positive, one is negative. We want the larger factor to be negative and the smaller factor to be positive. And if you're not sure of what those factors are, just use your calculator. There's no judgment. Okay. So we could get negative 18 and 3. And you might already know what this is going to simplify to, but just in case you don't, we're going to go through the motions. All right. So those are all of your pairs of factors of 54. So you have to ask yourself, which one adds up to negative 3? Well, negative 9 and 6. So if you didn't see negative 9 and 6 right off the bat, go through, make a list of all of your factors anytime, and just use your calculator. Anytime you get decimals, toss them out. When you get whole numbers, see which one adds up correctly. Play around with your signs. So we get negative 9 plus 6. Now, second numerator is again a quadratic trinomial. All right. And luckily the coefficient on the squared term is 1. So we start each binomial with an x. So this factors into the product of two binomials. Now we need factors of negative 6 that add to 5. So we would use plus 6, negative 1. Now x plus 4, the second denominator, it doesn't factor. It's already as good as it's going to get. Now, in the third numerator, we have x minus 9. That's as good as it's going to get. That won't factor. And then in the denominator, we have 9 minus 3x. So let's take a look at 9 minus 3x. This is not in standard form. And this is something that came up earlier in this video. And then it came up in the first video that we did. We need to put this in standard form. Okay. So we want the lead term, negative 3x, and then the constant. Okay. Now, when we put this in standard form, it looks like our lead term is negative. So what do? We factor out a GCF, but we want to make sure that GCF is negative. So we factor out a negative 3, and that leaves us with x minus 3. So this last denominator is 3 times x minus 3. And you do have to go through the motions, okay? You have to put it in standard form and then look for a GCF. And remember, if your lead term is negative, your GCF has to be negative. So let's see if we can cancel anything. Well, let's see. X plus 4's cancel. X minus 3's cancel. X plus 6 is cancel. And x minus 9's cancel. So what does that leave us with? Well, we're left with an x minus 1. We're left with a negative 3. Everything else canceled. So my final answer is x minus 1 over 3. And you can put negative 3 like this, or you can write it like this and just put the negative out front. Okay, I would say generally speaking, you would probably see your answer like this. Okay, so that wraps up multiplying and dividing rational expressions. Okay, so make sure you know how to factor. Make sure you have at least a general understanding of just how fractions work. If you don't understand how fractions work, rational expressions are going to be mind-boggling. Okay, so without having a general understanding of fractions and without knowing how to factor, this is going to be really too difficult. Okay, so make sure you kind of know those two things before you tackle this topic of rational expressions. Okay, so with multiplying and dividing rational expressions, for dividing, just make sure it's written as multiplication, and then factor everything, cancel common factors top to bottom, whatever's left over, multiply that out, that becomes your final answer. But the good news is you don't have to actually multiply it out, you don't have to distribute, you don't have to FOIL, you can leave your final answer in factored form. Okay, so practice your factoring, make sure you have a general understanding of fractions, and then tackle this. And also go back and watch the first video where I just introduced rational expressions, where it talks about simplifying, okay? Because having an understanding of how simplifying works will help you in this video when we talk about the opposites, where we have to put something in standard form and factor out a negative. Okay, now the next video in the series is going to be on adding and subtracting rational expressions with common denominators. Now you might remember from addition that you kind of learn how to add fractions and subtract fractions where they have the same denominator first, then you learn how to add and subtract with different denominators. So the next video is adding and subtracting rational expressions with common denominators. All right, best of luck.